So here we have geometric formulas that you should keep in mind. In the previous lesson, we had looked at different shapes and really their properties, but this one really has formulas and applications of different questions that you may see. So here are some formulas that I really want to go over. So let's start with areas. With areas, the first one is for parallelogram, which is base times height. And really the most important thing is that you should always remember that the height is perpendicular to the base, which means that it always meets the base at 90 degrees. So if you're given one side of the parallelogram, you can simply multiply it by the other side. You have to multiply the base by the height, which means that it has to be drawn perpendicular to the base if it's not already shown in the figure. The second one is the trapezoid, and with a trapezium or a trapezoid, the formula is h times the summation of base, the first base and the second base, all divided by 2. And so this is a formula that you should just know. Again, in the previous lesson I said that the trapezoid is a figure which has exactly one set of parallel lines. And so really just using this formula, you can determine the area of the trapezium. The third one is a pretty neat formula because you can use this formula to really determine the area of the kite or the rhombus. It's half times d1 times d2, where d1 and d2 are the two diagonals in the shape. What people really do is that they usually split the kite or the rhombus into several triangles and then determine the area individually and then overall add the areas up. However, what you can really do is that you have the length of one diagonal and you just times it by the length of the other diagonal and divide that by 2 and you get the area. So this is a good formula you want to keep in mind. With a square, we all know that the side or the length of the square are equal, which means that the formula to find the area would be s squared or s times s, where s is the side length. And similarly for a rectangle, it would just be length times width or LW. And now these are just the formulas, areas for figures, quadrilaterals, and more than that. And when you find the perimeter, that's just the outside length. So finding the perimeter of your trapezoid would mean that you have to add the lengths of each of the side of the trapezoid. So there's no really formula for that. Only rules could be applied there. But these are the area formulas that you should know. Now moving on to the next one is polygons. And just to give a basic overview of a polygon is really any figure that's enclosed. So if you see something that has a gap or is not completely closed, you cannot classify that as a polygon. But of course, all proper quadrilaterals like a square, parallelogram, a rhombus, or rectangle, these can be classified as polygons. And what a regular polygon means is that the side lengths of the polygon are all equal in measure and all of its angles are also congruent in measure. And so really the exterior angle of a regular polygon is 360 divided by n, as you can see, where n is the number of sides. And so if the number, or if the polygon is regular, then, and you know that the sum of the exterior angles in any polygon is 360 degrees, it makes sense that you can divide that by n to determine each or measure of each exterior angle. So this is an important formula that you should know. And moving on to the next one, you have 180 times n minus 2. Now this is a formula that you can use to find the sum of the interior angles in any n-sided polygon. And if you think about it, if that polygon is regular, you can further divide this value by n to determine the measure of each interior angle. Knowing that an interior angle and an exterior angle add up to 180 degrees, what you can do is, whatever value you get from here, you can subtract that from 180 degrees to get the exterior angle, which you could also derive from 360 divided by n. So these formulas, there is a link, there's a connection, which I will show in one of the later examples or the questions that I've shown here. The next, and the final formula that you should know is how to compute the number of diagonals. Now this is founded by doing n times n minus 3 all divided by 2. And there is a proof for this, but this is the main formula. And obviously you can check your work. So say you have a square. You know the number of diagonals is 2. 4 minus 3 is 1, times by 4 is 4, and divide that by 2 you get 2. So for a square, and you do that for a rhombus or a rectangle, you will see that there are two diagonals in each of those quadrilaterals. So here are some questions that I've made up here, which really test your knowledge. So determine the area of the following isosceles trapezoid, or a trapezium. So looking at this, assuming that this wasn't given, all we really had, because I solved this problem. So what the question originally was that you have 17, you have 13, and you have the 29. Now this being an isosceles triangle means that the length from here to here must be congruent to the length from here to here. And so that means that if you have 13, what's 29 minus 13? It's 16. Divide that by 2, you get 8 and 8, which makes sense because being an isosceles triangle, you know that these two triangles must be equal. So if this is 17, this is 17, this is 8. Of course this is 8. And you should know that 8, 15, 17 is a Pythagorean triple because it satisfies the Pythagorean theorem, which is a squared plus b squared is equal to c squared. You know that 225 plus 64 gives you 289. Therefore, this is a Pythagorean triple. Now, you know that this is 15, which means this is the altitude. So, if you know the altitude, you know the bases, you can just substitute those values in for the formula. So, doing base 1 plus base 2 times by height, all divided by 2, you should get 315. But again, always remember to label your units. So in this case, since you're finding the area, your final answer would be 315 units squared. Moving on to the second question, we have determine the exterior angle of a regular hexagon. And so again, with a hexagon, you know that it has 6 sides. And knowing that the formula is 360 divided by n, you really do 360 divided by 6 and you get 60 degrees. But now if you look at this question and you want to use this formula, you could still do that. If you do 180 times n minus 2, you know the sum of the interior angles of a hexagon, not necessarily regular, obviously whatever type of hexagon, you can find the sum, and doing that, you can compute that value, but you know that it's regular, so whatever result you get, divide that by n, or in this case, 6, to determine each interior angle. In this case, that value would be 120 degrees. And subtracting that from 180 degrees, you get 60 degrees because the sum of an interior angle and an exterior angle is 180 degrees. Therefore, subtracting 120 from 180 degrees, you get 60 degrees, which is your value. Whether you use 360 divided by n or this formula and then subtract that value from 180 degrees, your answer should be the same. But obviously, we all prefer 360 over n because it's a much quicker method. Question 3 is determine the number of diagonals in a nonagon. And again, a nonagon is really a nine-sided figure. So substituting 9 into the formula, we get 9 times 9 minus 3 all divided by 2, which is really 9 times 6, 54 divided by 2, which is 27. So a nonagon has 27 diagonals. So these are some geometric formulas and problems that you will see, especially if you can really apply these formulas well. So thank you for watching.